Hello and welcome back to the channel, students. So in today's topic or today's video, we are going to discuss what are the types of certs. But first of all, before we continue the topic of certs, those who have not watched the video of what is cert, for them, I have mentioned the link of that video in the I button and also in the description below. So kindly please watch them because we are going to have many videos based on the certs or the series of certs. So in today's video, we're going to discuss especially about the types of certs. So when we discuss the types of certs, basically there are two types of certs which we have. The first is a pure cert, and the second one which we have is the mixed cert, right? Now, what is the most important element which gives you the clear idea that the given number is a pure cert or a given number is a mixed cert? Obviously, if it is not a pure, then it has to be mixed. If it is not a mixed, then it has to be a pure. That's how it works. Now, let me give the very simple way of identifying. So the way of identification or the clear idea will give you your radicand number. So to identify whether the given number is a pure cert or whether it's a mixed cert, your radicand will play a very important role. In what sense? If your radicand number is a product, see, whenever I say a word product, that means it's something into something, right? It's a product of a perfect square number and non-perfect square number, then that cert will always be a mixed cert, right? I repeat once again. If your radicand is a product of perfect square into non-perfect square number, then your number will always be a mixed cert. But if your radicand doesn't follow this condition, then it's 100% pure cert, right? Now let's understand this by taking few examples, right? Let me write few examples over here. And my example goes like this. So the examples are, let's say the number root 2, 2 root 3, 3 root 7, root 8, and root 27. Okay, so these are the 5 certs which I have written. Now, obviously they all are certs, right? So that is most important because they all are certs. The only thing is that either of them are going to be mixed or either of them is going to be the pure, right? Now, what is the first and foremost condition? The very important condition which we have to look upon is the radicand. So let's look at the radicand. Now, radicand is this position. I hope everyone knows what is a radicand. So in the root 2, radicand is 2. In the number of 2 root 3, radicand is 3. In the third 3 root 7, the radicand is 7. In the third root 8, 8 is a radicand. In the third root 27, 27 is a radicand. So these are the radicand numbers or the values which we have, right? Now, what is a condition? Your condition or your radicand should be a product of a perfect square into non-perfect square. Let's see that how we can write the factors of 2. I can write the factors of 2 as 2 into 1. Yeah, obviously, I cannot write other than that because 2 is a prime number, or rather the smallest prime number. And you know that a prime number is a product or the factors of 1 in itself, right? So I cannot write further more than that. So therefore 2 cannot be written as more further, or it cannot have any other factors other than 2 and 1, right? So now, since this number doesn't have any perfect square number as per our condition, so therefore this is a pure cert, right? So this is a pure cert. Now let's go to 2 root 3. Now again, what is the radicand? Radicand is 3. Again, 3 is a prime number. And you know that a prime number again has a factors 1 in itself. So when I write the factors of 3, I get 3 into 1. Now that means again, I don't have any perfect square number into that product of radicand. So therefore again 2 root 3 is a pure cert. Is that clear, guys? Okay. Let's go to the next one, which is 3 root 7. Again, the radicand is 7. And again, when you check the radicand and the factors of radicand 7 can be written as 7 into 1 because again 7 is a prime number. So that means again it will be always written in the form of 7 into 1. So we do not have any perfect square number. So therefore again it's a pure surd, right? So this is what we have. Clear? So these are the first three surds are the pure surds. And let's go to the last two numbers, which we called as the, obviously let's check out that. Now when we talk about root 8, now let's write the possible factors of 8. 8 can be written as 8 into 1. It can also be written as 4 into 1, right? And obviously I'm going to take the second one because it has more divisibility on the reduced numbers we have. And when can I write root 8 as 4 into 2? And I can definitely see that a 4 is a perfect square, isn't it? You have to always write your number into its highest perfect square value, right? So that's always remember, guys. So now here 4 is a perfect square, and which we can always take out outside the radical. And when I take out of the root, what I remain is 2. And so the answer of root 8 is 2 root 2. And now 2 root 2 is the pure form of the root 8, which we call as a pure surd. So we have converted here the mixed surd root 8 into the pure surd of 2 root, right? So always remember, a mixed surd can always be converted into a pure surd, right? So that's very important thing. And the next thing which we have is a root 27, and which we can very well write as 9 into 3. And whereas 9 is a perfect square, now here the combination of perfect square into non-perfect square is coming into play. So therefore, so whenever a radicand is a product of a perfect square into a non-perfect square, then a number is a mixed surd. So therefore, root 27 is a mixed surd which can be converted into pure surd as 3 root 3. Okay? So that's it, guys. I hope you have understood what is
hold me close till I get up,
and how can
time is barely on our side.
Right? So
I don't wanna waste what's left.
Please comment.
The storms we chase are leading us.